Hey guys, it's Miss Saller here. Just wanted to get you guys caught up on some stuff that you may or may not have picked up on with the sub when I was gone on Friday. So feel free to use this video if you need to kind of, get a better handle on this whole interest thing that you were talking about today with the sub. So basically, with this note packet that you should have copied down the sub, I just want to cover a couple things that I wanted to kind of point out and do some harder examples with. So basically, there's three formulas you need to feel comfortable with. This first formula is anytime you want to compound interest annually, so that just means yearly, that you only want to take interest once a year, which is really kind of unrealistic. We're not going to use this formula a whole lot, but it is still something that's going to show up every once in a while. So basically the things you need to know is that this p-value is what's called the principal amount, and basically that's how much money you're putting into your bank account at the beginning of whatever life cycle you're looking at with this bank account. So it's the money you're putting into the bank. The R is your interest rate, and that's always written as a decimal. So for instance, if you have 2% interest rate, you're really writing it as 0.02, so the same way we did with the population stuff last part of the chapter. The N is the amount of time in years you have the money in the account, and the A is how much money is left after that time period. So it'll give you how much money is in the account. So that'll be the amount you put in plus the interest you're kind of adding on there. Now the formula we're going to use more often though is this second formula, which is the A equals P times 1 plus R over K times all to the power of KT formula. And this is anytime you want to take interest more than once a year. So if you have monthly accounts where every month you take interest, which is what a lot of people do, your K value would just be 12. You're also going to see this T value in here. The T is just the number of years you're taking that interest. So K is the number of times per year you're taking interest, and T is the total number of years. So there's the big difference. So this is the formula I mainly want to focus on with you guys with this video today. So turn the page over, because I think you could probably do this Joe Daddy problem without too much problem. You're just plugging in and pretty much just plugging right into your calculator. When it gets harder is when you're solving for something besides A. So let's turn it over and actually look at this first question here with Millie. And it says Millie has $700 to invest at 9.5% annual interest rate, compounded monthly. She desperately wants to buy a used car she saw advertised for $4,200. Assuming the car is still available and the offer is still good, when will she be able to purchase the car? So let's write down what we have. So we have the principal amount. How much she's investing is $700. The interest rate that she's investing at is 0.095. Again, make sure you're writing that as a decimal. Compounded monthly is giving us the K value is 12. And we know that the amount that we're trying to get to is the $4,200. That's how much she needs to buy the car. What we're looking for is the time in years. So we're looking for how many years it's going to take her to build that up. So we're plugging into that formula for the K times a year one. So A equals P times 1 plus R over K, all to the KT. And let's plug in the values we have. So we have 4,200 for A equals P is the 700 times 1 plus R is 0.095 all over K, which is 12, all to the 12T. And T is what we're looking for. So first we're going to divide by 700 because we want to get that exponent by itself before we do anything else. So divide by 700, and you get 6 equals 1 plus 0.095 all over 12 to the 12T. Now this is some yucky number. So what I'm going to do at this point is move over to my calculator and figure out what that yucky number is. And we're going to keep it stored in our calculator. I'm going to show you how to do that. So let's go over to our calculators and figure out what that this yucky parenthesis number is. So let's go in here and let's plug that in. So we have 1 plus 0.095 divided by 12. And again, you're going to get this really nasty decimal out. So what we're going to do is we're going to store that. So you have that little store key next to the 1. I showed you guys that earlier. It's down here by the on button. Press store. And you can store it as anything you want. I'm going to store it as X, so just use the X key up here right next to the alpha key. But you can do alpha A, alpha B, whatever you want to do to store that. So we're going to store it, and then when you press enter, notice how it spits out that number. So anytime you press X, you're going to get that number popping out. Okay, so now let's go back in here and write that down. Now just for writing down purposes, I'm going to write this down as a decimal, but then of course keep in mind it's really this yucky decimal. Alright, so we get 6 is about, though, 1.008 to the 12T. So now to solve for T, this is where our logs come in. So we're going to write this as a log. This is a log with a base of 1.008 of 6 is equal to 12T. So let's figure out what this is using change of base formula. So I'm going to do the change of base on that. So we're doing log of 6, close the parenthesis, divided by log of the base, which is that X number. Okay, that number, that yucky thing that we have right there. So make sure you do log X. close parenthesis, and we get 227.22 approximately. But again, I'm leaving this in my calculator. I'm not really rounding it. Okay, so we have about, though, 222.27 is equal to 12t. And now we're going to divide by 12. So take that, divided by 12, and we get 18.94. So time is about 18.94 years. And if I was going to talk to Millie, I would tell her, hey, maybe you want to get a better car, or maybe you want to put more money in the account, because obviously 19 years to wait for a car is a little bit too long. But anyways, that's the end of that problem. That's how you do it. So eventually get to logs, and it's a lot of calculator work, guys. Make sure you're storing and not rounding again and getting a lot of error. So now let's look at this Chunky Monkey problem, which in this problem, Chunky Monkey has $2,500 to invest. So again, already we know what he's putting in. So our principal amount is $2,500. What annual interest rate? So what we're looking for in this case is the R. We don't know what that is. Compounded quarterly, so we know the K value is 4, is required for him to double his money in 10 years. So we know the time that he's going to have it in there is 10 years. We're trying to double the money, so we know the amount he wants to get to is 5,000. Okay, so he started out with 2,500, he's trying to double it, he's trying to get to 5,000. So again, we're plugging into that same equation. So our amount, which is 5,000, is going to equal, the principal amount is 2,500, times we have 1 plus R is what we're looking for, all over K, which is 4, all to the 4 times T, so 4 times 10. So I'm going to divide both sides by 2,500, and that's always your first step, guys. Get that constant out of there in front. So you get 2 equals, we're going to have 1 plus R over 4 to the 440. 4 times 10 is 40. And now, to get rid of that, we're going to have to take the 40th root. We're undoing an exponent, so we're taking a root. So there's 2 ways you can do this in your calculator. So we're just going to have the 1 plus R over 4 here, but again, this is some yucky decimal. No one in the right mind knows what times itself 40 times gives you 2. So we're going to go into our calculator at this point again. And there's 2 ways you can do the 40th root. One way is type 40 first, and then go into the math key, scroll down to option 5, which is the xth root, and then plug in 2. Or you can take it to the 1 over 40 power, okay, because the 1 over 40 power is the 40th root. So you can do 1 to the 1 over 40. Make sure if you have the old calculator, unlike mine, that you put parentheses around that fraction if you're doing that. And again, you get the same answer. We get about 1.017. And again, I'm keeping it stored in there. This is not an actual answer, it's a rounded answer. So then subtract 1. And then we get about 0.017 is equal to R over 4. And then multiply by 4. Now we get 0.0699. I'm actually rounding to 4 decimal places because I'm rounding before I move the decimal, because I'm going to eventually change this into a percent, move the decimal over. So this is going to be R is about 0.0699, which if I write that as a percent, let me just erase this, that looks terrible. If I write this as percent, it's going to be 6.99%. Is the interest rate. So almost 7% Chunky Monkey would have to get to make that work out. So again, kind of giving some financial advice here. Chunky Monkey, I don't know what bank you're going to go to that gives you 7% interest these days. You might want to put more money in if you want to invest and get more money out, or you're going to have to leave it in there for a longer period of time. Just give them some sound financial advice. Now the last formula you guys need to know, and I'm not going to do any examples with this because again, it's a lot of calculator plugging in for these examples, is the compounding continuously formula. And this is the one that Gauss came up with, or sorry, Euler came up with, because he had that whole E idea to compound continuously. We talked about that earlier in the class. And again, what this will do, and all these things are the same, you have the principal amount, you have your R interest rate written as a decimal, you have your T as your time in years, your amount that you're going to have after that time in years. But what's different about this is will always be the best one, because compounding every second of every day will always give you more interest than any of our other 2 methods. But unfortunately, banks today do not really use this. You'd be hard-pressed to find a bank that compounds continuously. But again, you plug this in, plug in your values, solve, and you'll be able to solve using the same methods we talked about before. So hopefully, guys, this will give you enough to kind of help you get through tonight's homework. So if you have any questions, though, drop by Monday before school. I'll be happy to help you get through that homework that you guys have. But hopefully this will help you get started in that homework. And we will be spending some time on Monday kind of reviewing this, but I do expect that after seeing this video and looking at the notes the sub gave you from this packet, you should be able to do the homework. And I hope this video helped you out, guys. I'll be doing this again in the future.